Welcome to this peaceful sanctuary of quiet thought and gentle curiosity. As we begin our journey together through the quiet realm of the sky, you may notice the screen before you softly dimming, allowing the visual picture to fade away to darkness after the opening card. As you settle in, close your eyes and let your body find an effortless rest. Take a deep, slow breath, releasing the tensions of the day, and let your mind sink into the steady, soothing cadence of the atmosphere. Tonight, we turn our gentle attention to the serene science of cloud formation, exploring how invisible moisture weaves itself into quiet tapestries of white and blue. Above us, the atmosphere is a living engine, continuously breathing and circulating in silent harmony. Long before humans understood the precise physics of air currents, we looked up at the drifting shapes with wonder, seeking a language to describe the changing moods of the heavens. For centuries, the sky has offered this same restful spectacle to all who seek tranquility beneath its endless span. In the quiet winter of December 1802, English chemist Luke Howard presented his Latin classification of clouds to the Ascian Society in London, giving peaceful names like cirrus and stratus to the soft, floating shapes of the sky. Prior to his presentation, the transient forms drifting overhead were often considered too ever-changing to be organized into distinct categories. Yet Howard recognized that beneath their shifting forms lay order and quiet structure, governed by natural laws that operated with predictable gentleness. By choosing classical Latin roots, he gave science a poetic lexicon that transcended national boundaries and time itself. He called the high, wispy strands that curl like locks of hair cirrus, meaning a tuft or curl, while the low, horizontal layers that stretch across the horizon like a soft blanket were named stratus, from the word for layer or sheet. In doing so, he offered a gentle framework for observing the subtle poetry of atmospheric rhythms. To observe clouds with a quiet mind is to witness the atmosphere expressing its delicate thermal balance. Water, in its invisible gaseous state as vapor, rises gently from oceans, lakes, and damp soils, carried upward by subtle warmth near the Earth's surface. As this warm air ascends into the cooler upper layers of the sky, it expands and cools, reaching a quiet threshold where it can no longer hold its moisture purely as a gas. Here, condensation occurs, transforming invisible vapor into tiny liquid droplets or microscopic ice crystals that gather around specks of dust or sea salt suspended in the air. These microscopic particles, known as condensation nuclei, act as delicate anchors for the water to cling to, forming the soft, floating shapes that grace our skies every day. As we rest here in the stillness, surrounded by the invisible currents of the air, let your thoughts drift as light and unburdened as those high cirrus strands. The atmosphere overhead is quietly holding us, orchestrating a continuous cycle of water and energy that sustains all life while remaining endlessly gentle and calm. There is no hurry in the movement of the clouds, only the natural unfolding of atmospheric laws in their own perfect time. Settle deeply into this quiet rhythm as the darkness wraps around you, listening to the soft story of the sky as it unfolds, breath by breath. As dusk settles softly over the quiet landscapes of Northern Europe, the atmosphere begins its evening lull, drifting into a rhythmic, steady breathing. Long before modern satellites and digital sensors peered into the upper reaches of our skies, early weather observers found peaceful, meditative ways to read the subtle movements of the air above. In 1878, Swedish meteorologist Hugo Hildebrand Hildebrandsson constructed a mirror nephoscope in Uppsala, using a circular black glass reflection to silently trace the slow, gliding direction and speed of high cirrus clouds across the sky, resting horizontally on a steady wooden frame. This dark, polished disc allowed the observer to watch the delicate, feathery tendrils of cirrus move without the glare of the bright sun, transforming the vast and restless expanse of the heavens into a contained, tranquil reflection. Through the smooth surface of the dark glass, the distant, swift winds of the upper troposphere lost their harshness, revealing instead a serene and predictable aerial drift. These high-altitude clouds, formed from microscopic ice crystals suspended miles above the Earth, carried subtle clues about distant atmospheric currents. Yet, when observed in the calm depths of the nephoscope mirror, they offered a soothing visual rhythm that invited a patient, quiet contemplation. Beneath these high, wispy veils, closer to the resting Earth, another silent wonder unfolds within the heart of every passing cloud. We often picture clouds as simple, pure vapors of water floating freely in the sky. Yet the birth of every cloud droplet requires a subtle, hidden catalyst. In 1888, Scottish physicist John Aitken built a dust counter in his Falkirk workshop, discovering that every gentle cloud droplet forms around an invisible seed of mineral dust, or sea salt. Working thoughtfully within his quiet workshop, Aitken revealed that without these tiny suspended particles, known today as cloud condensation nuclei, water vapor would linger in the air without gathering into visible mist. Microscopic specks of soil carried gently upward from dry riverbeds, alongside tiny ocean salt crystals lifted by ocean breezes, drift silently through the atmosphere, offering welcoming surfaces where water vapor can settle. As the surrounding air cools in the softening light of evening, water molecules gracefully condense around these hidden centers, forming tiny spherical droplets that linger together to create the soft, protective canopy of clouds overhead. Together, these early scientific insights remind us that the atmosphere is not an empty space, but a vast, living tapestry of interconnected physical processes working in peaceful harmony. From the expansive, high-altitude arcs of cirrus, tracked silently across a Swedish reflection disk, to the microscopic condensation occurring around a single grain of sea salt in Scotland. The sky moves to a steady and soothing cadence. Each droplet and each cloud filament plays a part in balancing the temperatures and moisture of our world, maintaining an ancient equilibrium that cradles the earth below. As the light fades completely into night, the air continues its quiet, unseen labor, weaving together dust, salt, water, and ice into a calm atmosphere of safety and calm. The slow, perpetual drift of clouds becomes a gentle reminder of nature's quiet order, easing our thoughts and lulling the mind into a deep, restful peace. High above the quiet fjords of northern Norway, perched upon the windswept solitude of a remote mountain peak, the Hald Observatory once rested beneath vast and silent Arctic skies. It was in this peaceful, isolated sanctuary of early atmospheric science that research proceeded at a slow, meditative pace, far removed from the bustle of the modern world. In 1921, Swedish meteorologist Hilding Kurtler formulated his cloud droplet equilibrium curves at the isolated Hald Observatory in northern Norway, describing how invisible moist air particles quietly cross a critical size threshold to blossom into floating cloud drops, working amidst the deep stillness of northern winters. Kurtler sought to understand the microscopic origins of mist and cloud, seeking the precise mathematical harmony that governs the transition from clear air into visible vapor. His groundbreaking curves mapped out the delicate relationship between environmental humidity, the curvature of tiny water droplets, and the chemical nature of microscopic salt particles floating invisible in the air. In doing so, he revealed that cloud formation is not a chaotic burst, but a deeply orderly physical progression, where microscopic seeds of water patiently respond to subtle shifts in thermodynamic balance until they naturally take form in the open sky. This tranquil transformation begins in the unseen depths of the atmosphere, where endless numbers of aerosol particles gently drift on silent air currents. These tiny condensation nuclei, microscopic specks of salt swept up from ocean spray, tiny mineral grains, or soft traces of atmospheric compounds, serve as resting places for water vapor molecules wandering through the cool air. As the surrounding humidity softly increases, water vapor settles upon these microscopic seeds, forming a delicate liquid shell. At first, the growing droplet remains in a restful equilibrium, absorbing and releasing water vapor in equal measure as it balances the opposing physical forces acting upon it. The sharp curvature of a tiny drop encourages water molecules to evaporate back into the air, while the dissolved salt within draws moisture inward. Bit by bit, as moisture gently accumulates, the droplet swells, navigating a smooth curve of physical equilibrium. When humidity reaches a specific, gentle peak, the droplet reaches its critical size threshold, a quiet tipping point where surface tension no longer restricts its growth. Beyond this invisible boundary, the droplet expands effortlessly, drawing in water vapor spontaneously to become a stable, floating cloud drop that light can softly scatter. There is a profound comfort in contemplating how the grand visual landscapes of the atmosphere are built upon such quiet, micro-scale rhythms. Across the globe, this gentle sequence plays out continuously without making a sound, filling the upper air with soft veils of stratus and floating towers of cumulus. The atmosphere does not hurry its creations. It simply allows cool air to rise, humidity to build, and physical thresholds to be crossed with calm certainty. As twilight deepens and night settles over the landscape, the air slows its movement, holding millions of these newly blossomed droplets in peaceful suspension. They drift over mountains, valleys, and quiet sleeping fields, reflecting the faint ambient light of the stars and moon. To listen to the story of cloud droplets is to rest in the knowledge that nature operates through quiet balance, orderly transitions, and silent, steady laws that maintain the soothing equilibrium of our atmosphere. High above the rolling glens of the Scottish Highlands, the atmosphere moves with a patient, unhurried grace. Here, where granite peaks reach into the cool upper air, moisture carried on gentle breezes meets the quiet chill of the heights, drifting softly into pale banners of mist. In the quiet early hours before the world awakens, the air holds a delicate moisture, balanced perfectly between invisible vapor and floating droplet. As dawn touches the horizon, light filters through these high-altitude mists, bending softly around every tiny drop to cast glowing rings and subtle pastel halos across the mountain slopes. The mountain summit becomes an observatory of stillness, a place where the subtle laws of thermodynamics are written not in ink, but in the slow drift of water suspended against the sky. In this serene space, the air feels weightless, carrying the tranquil rhythm of an atmosphere continuously breathing in and out. It was in this tranquil high-altitude sanctuary that the mystery of cloud creation first revealed its inner mechanics to a patient observer. During the summer of 1894, Scottish physicist Charles Thomson Rees-Wilson spent weeks observing sunrise optical mists atop the lonely summit of Ben Nevis, an experience that inspired him to construct the world's first cloud chamber in a quiet laboratory. Sitting quietly amidst the shifting vapors of the peak, he watched the morning sun paint luminous coronas upon the fog, fascinated by how nature crafted such exquisite brilliance from nothing more than water droplets floating in air. He wondered how such subtle beauty could be brought indoors, preserved within glass, so that the secret lives of clouds might be studied at rest. Returning to his laboratory, he set to work creating a sealed enclosure where moist air could expand and cool on command, reproducing the gentle chill of the mountaintop within a small, peaceful vessel. Inside his carefully crafted chamber, Wilson discovered that clouds do not form in isolation. They require delicate seeds around which invisible water vapor can gather and condense. When air expands and its temperature softly dips, water molecules slow their ceaseless motion, searching for microscopic dust particles or charged ions to embrace. Upon finding these tiny anchors, the vapor softly coalesces, forming tiny droplets of liquid light that linger in suspended equilibrium. The cloud chamber thus became a microcosm of the vast sky above, revealing that even the most invisible particles passing through our world leave faint, beautiful tracks of mist in their wake. As we drift toward sleep, we might picture these microscopic droplets forming quietly in the cooling night air, each one a tiny world of liquid tranquility, reflecting the immense, quiet sky. Across vast atmospheric landscapes, this same gentle process unfolds countless times every single moment. Above silent valleys, over sleeping oceans, and across high timbered ridges, invisible vapor cools and transforms into soft, pillowing clouds that cradle the earth in shade. The atmosphere moves in an eternal, soothing cycle, rising to cool and descending to warm, maintaining a harmonious temperature that sustains all life below. Resting beneath this grand blue canopy, we can take comfort in the steady, timeless rhythm of cloud formation, knowing that the sky is endlessly working to balance heat and moisture, wrapping the world in a quiet blanket of air as the day slowly turns to night. High above the quiet earth, the atmosphere holds its breath in a silent dance of temperature, pressure, and invisible moisture. Every cloud that floats across the twilight sky begins as a soft whisper of water vapor, carried upward by gentle thermal currents into colder, thinner air. As air ascends, it slowly expands and cools, losing its capacity to hold moisture in gaseous forms. Water molecules, floating freely in the warm lower air, begin to slow down as the temperature drops, seeking tiny particles of dust, sea salt, or pollen upon which to gather. These minute kernels serve as condensation nuclei, giving the ambient moisture a foundation upon which to condense into microscopic droplets of liquid water. When billions of these tiny droplets coalesce, a cloud gently forms, catching the fading light of evening in shades of pearl and lavender. Yet, when temperatures high above drop well below freezing, water often remains liquid in a delicate, supercooled state, waiting for the slightest prompt to transform into glinting crystals of ice. This serene balance between liquid fog and frozen crystal underpins the quiet majesty of high cirrus clouds drifting peacefully over sleeping landscapes. The subtle mechanics of this atmospheric transformation remained partly obscured until the quiet summer of mid-20th century research, when laboratory curiosity met the vast mysteries of the weather. In July 1946, American scientist Vincent Schieffer breathed into a chilled laboratory box in Schenectady, New York, lowered to minus 40 degrees Celsius. Watching his breath turn into a soft fog that crystallized into millions of microscopic, floating ice diamonds. This quiet laboratory observation revealed how supercooled cloud droplets, held in a suspended state high in the sky, require a sharp plunge in temperature or specific freezing nuclei to initiate their crystalline transformation. When the air reached that threshold of extreme cold, even the moist exhalation of a human breath provided enough water vapor to instantly freeze into a delicate shower of microscopic ice prisms. The tiny ice diamonds glistened briefly in the laboratory lamp before floating downward, mirroring the exact physical process that occurs high within winter clouds miles above the Earth. Schiefer's simple, elegant experiment opened a new era in meteorology, showing that the birth of ice in supercooled clouds could be observed in a small, quiet box of cold air. As night falls and the ground cools, these same atmospheric principles continue their slow, rhythmic work across the expanse of the sky. In the upper troposphere, where temperatures perpetually hover below freezing, supercooled water vapor, and ice crystals drift in peaceful equilibrium, painting delicate feather-like trails of cirrus across the starlight. Each crystal grows at its own unhurried pace, absorbing moisture from the surrounding air as geometric patterns bloom across microscopic surfaces of ice. As these cloud formations drift slowly across thousands of miles, they help regulate the thermal rhythm of our planet, reflecting distant sunlight during the day and insulating the Earth gently through the cold dark of night. The air above us remains a vast, quiet sanctuary of thermodynamics, where simple changes in temperature create breathtaking structures out of nothing more than breath and sky. Listening to the quiet rhythms of the atmosphere, one can imagine those millions of floating ice diamonds slowly descending, bringing calm, restorative peace to the resting world below. In the stillness of a cool atmosphere, water lingers in quiet states of patience, resting as microscopic droplets suspended within the damp, shadowy air. There comes a gentle moment when these tiny drops encounter the threshold of frost, participating in a subtle, silent exchange of moisture that quietly shapes the winter sky. In February 1922, Swedish meteorologist Tor Bergeron noticed, while walking through a mist-shrouded pine forest near Oslo, Norway, that fog droplets vanished near frost crystals on branches, leading him to describe how ice crystals quietly draw vapor from surrounding water droplets to create soft snowflakes in cool clouds. This tranquil mechanism reveals how water molecules migrate smoothly through the dark air, relinquishing their liquid form to nourish the expanding arms of ice. Within the calm sanctuary of cool clouds, where temperatures hover just beneath freezing, countless supercooled liquid droplets coexist alongside sparse, emerging ice crystals. Because the saturation vapor pressure surrounding an ice crystal is slightly lower than that surrounding liquid water, the liquid droplets slowly evaporate into the cold atmosphere, sending their invisible vapor drifting toward the ice to be gathered into serene, geometric patterns. It is a soft and steady rhythm high above, where liquid surrenders to solid without any haste, allowing clouds to weightlessly build the gentle snowfall that eventually drifts toward the sleeping earth below. Years later, across the sea, scientists sought to listen even more closely to this subtle whisper of atmospheric physics, reproducing its quiet magic in peaceful laboratory isolation. In December 1936, Japanese physicist Yukihiro Nakaya produced the world's first artificial snowflake inside a cold basement laboratory in Hokkaido, growing delicate ice crystals on a single strand of rabbit hair suspended in calm, humid air. Working beneath the deep winter snows of northern Japan, Nakaya created a miniature atmosphere within an insulated chamber, carefully balancing humidity and thermal currents to watch how frost blooms in slow, intricate symmetry. By observing the growth of ice upon that single fine thread, he realized that every snowflake carries the silent story of its journey through the sky, acting as a tiny, handwritten letter describing the precise temperature and moisture of the cloud layers it traversed during its slow descent. The delicate, star-like branches of dendrites and the smooth hexagonal columns both form according to minuscule shifts in surrounding vapor, unfolding with effortless harmony and steady grace in the stillness of his cold room. As the night deepens, these atmospheric rhythms continue silently overhead, suspended far above the resting world. Cloud vapors shift and transfer their subtle warmth into the cool night air, floating softly over slumbering valleys, sleeping hills, and quiet forests. Each crystal that forms is a testament to the peaceful balance between liquid droplets and frozen needles, suspended together in a calm, balanced cradle of night air. There's no hurry in the way a snowflake grows, nor in the way it slowly settles upon the pine boughs and sleeping fields below. The atmosphere holds them with soft care until they are ready to fall, wrapping the earth in a quiet blanket of stillness, rest, and peace. High above the quiet earth, where the atmosphere grows cool and thin, invisible water vapor performs one of nature's most delicate transformations. As moist air drifts softly upward into the frosty reaches of the upper troposphere, the thermal energy of floating molecules begins to slow, allowing the faint electromagnetic forces between hydrogen and oxygen atoms to draw them into a graceful, orderly lattice. Here, amidst the whisper of gentle high-altitude winds, water droplets do not merely freeze, they assemble themselves with quiet precision around microscopic specks of atmospheric dust or mineral particles, growing along rigid molecular angles determined by the laws of crystal physics. Each tiny ice crystal begins its life as a microscopic hexagonal prism, floating weightlessly within the soft blue domain of cirrus and stratocumulus clouds. As these embryonic structures drift through subtly varying currents of temperature and relative humidity, additional water vapor attaches to their delicate edges, extending 6 branching arms of intricate geometric symmetry. What floating cloud layers weave so quietly above our heads is an infinite gallery of crystalline art, constructed entirely out of invisible vapor, cold air, and time. For centuries, human eyes could only catch the briefest fleeting glimpse of these transient masterpieces before they melted upon a warm hand or vanished into the winter ground. It required extraordinary patience, stillness, and quiet devotion to capture the intricate geometry formed in the upper skies before it faded away forever. On January 15, 1885, in the quiet winter air of Jericho, Vermont, Wilson Bentley connected a microscope to a bellows camera and held his breath, capturing the world's first photograph of an individual hexagonal snowflake drifting onto cold black velvet, standing inside his unheated wooden shed, while the winter storm brushed softly against the farmyard outside. Bentley understood that these fragile structures were direct, beautiful messages sent down from the cloud layers above. His groundbreaking photomicrographs demonstrated to the world that while every cloud crystal obeys the exact same laws of atomic physics and hexagonal symmetry, no two snowflakes travel through identical atmospheric pathways, leaving each one uniquely sculpted by its own serene, unhurried journey through the air. When we look up at winter clouds drifting softly overhead, we are observing vast, floating reservoirs of these microscopic crystalline worlds. Within alto stratus and cirrus clouds, billions of tiny ice prisms align themselves in the quiet currents, bending incoming light from the distant sun and moon to create luminous halos and soft, pastel arcs across the evening sky. As these mature, fully formed crystals eventually drop from their atmospheric birthplaces, they fall with a steady, rhythmic slowness, cushioning the winter landscape below in a thick blanket of peaceful, insulating quietude. The atmosphere settles into a tranquil, reassuring rhythm, a slow circulation of moisture rising into cold perfection and returning gently to the earth. In this quiet cycle of condensation, freezing, and silent descent, the air reminds us of the calm order underlying the natural world, inviting the mind to rest deeply in the gentle, timeless balance of sky and ground. Imagine ascending slowly into the vast, cool stillness of the sky, where air grows light and quiet, leaving behind the lingering warmth of the sunlit earth below. As one travels gradually upward through the invisible ocean of the atmosphere, the surrounding air undergoes a quiet and continuous transformation, yielding its stored heat degree by degree into the expanding space around it. This natural, predictable cooling creates a gentle thermal ladder within the atmosphere, guiding rising currents of water vapor on their slow, drifting journey toward condensation. In this serene upper realm, where misty veils of cloud drift across the soft blue canopy, the atmosphere keeps time with an ancient and steady rhythm. The gradual fading of thermal energy at higher altitudes allows delicate, weightless droplets to gather without haste, resting quietly in the open expanse like soft, luminous cushions of suspended mist that float effortlessly above the turning world. The historical seeking of these high atmospheric rhythms often mirrored the peaceful stillness of the sky itself. September 1862, English meteorologist James Glaisher ascended high above Wolverhampton in a quiet wicker balloon basket, documenting how atmospheric temperature gently decreases by roughly 6.5 degrees Celsius for every kilometer climbed through cloud layers. Suspended beneath a vast envelope of silk, drifting silently through misty gray clouds into the clear, sunlit air far above, Glaisher watched the mercury in his thermometer sink with predictable, serene precision, floating far above the hum of the ground. His meticulous notes captured the gentle lapse rate that governs the vertical structure of our atmosphere. His journey demonstrated that as air rises into regions of lower pressure, it expands and cools in a quiet, mathematical harmony, establishing the thermal boundaries where invisible vapor is transformed into visible cloud. This continuous vertical cooling functions as a tranquil cadence, regulating how the lower atmosphere breathes through every cycle of day and night. As warm air that was gently warmed near the earth begins its unhurried ascent, it moves into regions of lower ambient pressure, steadily expanding without absorbing external heat. As it expands, its internal energy relaxes, bringing the air parcel down to its dew point, where it can no longer hold moisture in an invisible state. At this exact threshold of temperature, water molecules gather softly around microscopic particles of mineral dust, and sea salt that float suspended in the breeze. These microscopic condensation nuclei give shape to the floating landscapes of cumulus, stratocumulus, and cirrus that rest softly in the sky. The entire atmospheric process unfolds with an enduring patience, an unhurried drift from warmth to cool stillness, reminding us of the steady physical laws that maintain harmony across the sky. As twilight settles over the land, these elevated cloud decks catch the last fading rays of golden light, slowly darkening into deep indigo as the atmosphere settles into quiet rest. In this nightward breathing of the air, the lower sky gradually surrenders its turbulence, allowing the thermal strata to smooth out into still, silent layers. The gentle decrease in temperature that begins near the earth extends upward into the darkening quiet, carrying with it a profound sense of calmness. As the last traces of daylight fade behind the horizon, the atmosphere holds its breath in perfect equilibrium, offering a peaceful, quiet space for rest and quiet dreaming. As dusk settles softly over the landscape, the Earth's atmosphere engages in a slow, continuous dance of temperature and density, moving quietly across continents and oceans. High above the quiet Earth, vast masses of air meet not with turbulent collision, but with a graceful, unhurried embrace that transforms the sky into a canvas of tranquil gray. In October 1918, Norwegian meteorologist Jacob Bjerknes tracked air currents from his observatory in Bergen, discovering how warm air gently glides over colder air along a polar front to build a vast, sweeping shield of soft stratus clouds. This gentle incline, where a mild breeze steadily ascends over the heavier, cool air resting below, creates a smooth and widespread lifting motion across the horizon. As the rising warm air cools gradually in the peaceful upper atmosphere, its invisible vapor condenses into countless weightless droplets, weaving a seamless gray canopy that diffuses the fading sunlight into a soft, restful glow. This broad expanse stretches for hundreds of miles, a quiet blanket resting tenderly above the evening world, reminding us of the steady, silent dynamics that wrap our planet in comfort. Beneath this sweeping curtain of stratus, smaller thermal rhythms take shape in the mid-altitude sky, guided by the faint warmth radiating from the earth below. When air is warmed from underneath in shallow atmospheric layers, the rising heat arranges itself with surprising geometric elegance. In 1900, French physicist Henri Baynard heated shallow liquid layers in his Paris laboratory, discovering that rising thermal currents naturally organize into hexagonal convection cells, explaining the neat, repeating rows of floating stratocumulus cloud streets. Within the open atmosphere, these self-organizing convection currents create vast, beautiful fields of soft, rounded cloudlets separated by narrow lanes of clear, descending air. As warm air ascends gently through the center of each invisible cell and settles along its cool perimeter, the sky paints itself in rhythmic patterns of light and quiet shadow. The resulting cloud streets drift peacefully across the twilight horizon like soft, luminous cobblestones, demonstrating how fluids naturally seek harmony, symmetry, and quiet balance in their eternal motion. These atmospheric rhythms, operating on scales both immense and intimate, offer a deeply reassuring glimpse into the peaceful physics of the air. From the grand, sweeping glides along polar fronts to the delicate, geometric convection of stratocumulus clouds, every shift in the atmosphere is guided by gentle thermodynamic forces quietly seeking balance. The sky does not hurry its constant transformations. It breathes with a slow, steady cadence, lifting moist air into quiet cloud layers and letting them rest against the softening light of dusk. As evening slowly turns into night, these floating clouds drift on silent, high-altitude currents, shielding the earth below in a peaceful, darkening embrace. The mind, too, can settle into this rhythmic stillness, following the slow, predictable motions of warmth and cool air as they weave through the atmosphere, leaving behind a tranquil silence that invites deep, undisturbed, and restorative rest. As the warmth of the day gently yields to the cooling quiet of dusk, the vast atmosphere above begins to settle into soft, orderly layers. High above the sleeping earth, unseen currents of air drift with effortless grace, sliding past one another in a silent, fluid dance. The atmosphere is far from a simple static void. It is a boundless, living ocean of air, governed by the very same gentle physical laws that guide the quietest waters of the deep sea. In the calm twilight, when the winds near the ground soften to a tranquil hush, these upper atmospheric currents continue their measured journey across the darkening expanse. Here, where a warmer layer of air glides above a cooler, denser stratum beneath, a delicate boundary of temperature and density is quietly struck. The surface between these air masses is smooth, flexible, and deeply responsive to movement. As the last rays of sunlight fade into a soft indigo, clouds suspended within these drifting currents begin to adjust to the subtle nudges of the wind, preparing to display the peaceful, fluid motion of the upper sky. When two adjacent layers of air move at different speeds, a gentle shearing motion develops along their shared interface, sculpting the calm cloud vapor in remarkable ways. First described mathematically by Lord Kelvin in 1871, atmospheric shearing currents can smoothly shape a layer of stratus clouds into fluctus formations, creating long, tranquil rows of sky billows that mirror slow ocean waves. This breathtaking phenomenon unfolds with profound stillness far above the terrestrial landscape, rather than collapsing into turbulent agitation. The top of the cloud layer responds to the velocity difference by rolling into a series of elegant, repeating crests. Each delicate curl mirrors the gentle crest of a distant ocean, swell gliding toward a peaceful shore. The mathematical elegance captured in Lord Kelvin's classic work reveals a comforting and foundational order within atmospheric science, demonstrating how even variable winds obey laws of symmetry and proportion. To gaze up at these atmospheric billows is to witness physics expressed as soft white ribbons against the twilight, providing a soothing display of nature's structural harmony. As the evening deepens, these tranquil sky billows move slowly across the vast celestial dome, maintaining their wave-like geometry for many peaceful minutes before dissolving softly into the gathering night. Watching these serene cloud crests drift across the zenith brings a profound, quiet sense of stillness, as though the atmosphere itself were inhaling and exhaling in a slow, rhythmic lullaby. Below, the earth rests peacefully beneath this majestic canopy, safe and sheltered by the steady, protective layers of air that softly cradle our world. Eventually, as the difference in speed between the two air layers gradually balances, the distinct crests melt back into a smooth, seamless blanket of low stratus cloud. Every movement within the atmosphere, from grand planetary wind currents that circle the globe down to the smallest wave atop a quiet cloud layer, participates in this restorative balance. In the quiet solitude of the evening, the gentle science of atmospheric motion offers a peaceful reminder of the steady rhythms that constantly surround us, comforting the spirit and welcoming a deep, tranquil sleep. High above the silent slopes of ancient mountains, the atmosphere carries a rhythm all its own, shaping invisible rivers of wind into graceful, resting forms. When moisture-laden air encounters a solitary mountain peak, it does not break abruptly or scatter into wild chaos. Instead, it glides smoothly upward along the tilted contours of the stone, lifted into higher and cooler layers of the atmosphere. As this gentle current ascends, its temperature naturally drops, allowing invisible water vapor to slowly condense into floating droplets of mist. Upon reaching the crest of this airborne arc, the current begins its quiet descent down the leeward slope, warming as it lowers and allowing the moisture to gently dissolve back into clear air. This rhythmic rise and fall creates what meteorologists describe as a standing wave, an unseen ripple held motionless in the sky, where air flows continuously through a pattern that remains perfectly stationary. To watch such a wave form from below is to observe a quiet harmony between solid earth and fluid sky, where motion and stillness balance one another in perfect peace, where these atmospheric waves remain steady over elevated terrain. They often give birth to extraordinary cloud formations that seem to hover without moving, hovering motionless for hours over Japan's Mount Fuji. Smooth lenticular clouds, known as tsurashigumo, form when gentle mountain crest winds create invisible, stationary airwaves where moisture continuously condenses and evaporates in soft equilibrium. Though strong alpine winds may be sweeping across the peak at considerable speed, the cloud itself remains anchored in place like a serene saucer, or a stack of smooth porcelain discs resting softly against the sky. Water molecules stream into the upwind edge of the cloud, condensing into tiny visible droplets precisely at the crest of the invisible wave, only to evaporate back into transparent air as they ride the current down the opposite side. This seamless, unending exchange creates a remarkable illusion of absolute permanence, a cloud that appears as still as stone, even as an endless river of air flows steadily through its soft, luminous structure. Historically, observers of mountain weather spent centuries studying these silent sky sculptures, learning to read their delicate shapes as signs of stable wind patterns flowing across the upper atmosphere. The gentle symmetry of lenticular clouds reveals how the atmosphere behaves much like a deep, tranquil river flowing over hidden stones on a riverbed. Just as water ripples over a submerged boulder and forms a smooth, unbroken wave on the surface, the air glides over majestic mountain ranges and forms quiet crests of mist high above the ground. As afternoon transitions into the quiet calm of evening, the changing light touches these mountaintop clouds with warm, subdued tones of soft peach and twilight purple. The air slows its pace across the high terrain, and the stationary waves begin to ease into gentler gradients, settling the surrounding atmosphere into a deep state of repose. In the quiet darkness after sunset, as the ground cools and the mountain breeze falls into a soft hush, the invisible air waves gradually relax. The condensation within the standing cloud thins until only the faintest veil remains, floating silently under the emerging stars. The atmospheric rhythms that shaped the afternoon sky now rest in quiet stillness, holding the quiet valley below in a peaceful, restful sleep. As twilight softly settles over the vast horizon, the atmosphere carries out its quiet work, moving air in steady, gentle currents that ripple through the sky like slow, rhythmic waves across a calm and tranquil sea. The air above us is rarely truly motionless, yet its grand movements occur with such deliberate grace and quiet poise that they bring a profound sense of peace to anyone observing from the ground below. Throughout history, thoughtful observers of the heavens have looked upward to understand these subtle thermal shifts and the delicate, continuous dance between invisible water vapor and surrounding air temperatures. In 1894, English meteorologist William Clement Lay published his treatise Cloudland, detailing how cool, moist air gently subsides into drier air to form smooth, rounded mammatus pouches along the underside of a peaceful cloud layer. These soft, pillow-like pockets hang down into the quiet lower atmosphere, casting gentle, muted shadows across the base of the clouds as the late evening sun glows softly behind them. They serve as a quiet reminder of how delicate temperature differences can craft breathtaking visual wonder without any sound, turbulence, or disruption, creating a soothing overhead canopy that lingers gracefully in the twilight air before dissolving softly into the darkening night sky. Across distant regions of the world, atmospheric waves continue to weave unique, grand patterns that flow smoothly over continents and open oceans alike. In the far northern reaches of Queensland, Australia, the surrounding atmosphere undergoes an extraordinary annual ritual where coastal moisture, morning sea breezes, and subtle atmospheric pressure gradients align in perfect, peaceful harmony. Every October near Burketown, Australia, solitary atmospheric waves form the morning glory cloud, a smooth, cylinder-shaped cloud band stretching up to 1,000 kilometers across the calm morning sky. Rolling slowly across the vast waters of the Gulf of Carpentaria, this magnificent, rolling tube of white cloud moves with a steady, soothing momentum, gently condensing moisture at its leading edge while evaporating it along its trailing boundary. To stand beneath such a vast, continuous wave is to witness the calm rhythm of the Earth's atmosphere operating on an immense scale, where solitary wave fronts move quietly through the morning twilight, perfectly balanced and effortlessly smooth across the endless horizon. These remarkable atmospheric phenomena highlight the hidden, elegant architecture of our air, where invisible waves and gentle temperature layers form predictable, deeply restful patterns across the entire globe. Whether in the quiet pocketing of Mammatus beneath a sunset cloud deck, or the majestic, linear sweep of a solitary morning cloud cylinder, the sky continually demonstrates a natural order driven by balance, harmony, and profound tranquility. Air rises softly, cools, settles, and flows onward in a perpetual loop, maintaining an unending rhythm that has shaped our living atmosphere for countless millennia. Each passing cloud layer contributes to this tranquil equilibrium, weaving together light, vapor, and gentle thermal currents into a soothing blanket. As night deepens and the ground below grows completely calm and still, these vast atmospheric rhythms gently cradle the cooling air, floating softly above the sleeping landscape. There is a deep, quiet comfort in knowing that far above us, these gentle currents continue their timeless, tranquil journey through the night sky, carrying the peaceful story of atmospheric harmony into the quiet darkness. As twilight gently breathes across the atmosphere, the physics of suspended moisture unfolds in quiet harmony with the lingering rays of the setting sun. High above the darkening landscape, countless tiny droplets of water remain suspended in midair, balancing effortlessly between gravitational pull and the gentle, subtle updrafts of cool evening air. Each individual sphere of liquid water acts as a minute, perfect optical lens, taking in the pale golden light that filters through the receding shower. When white sunlight enters these floating drops, it slows down and bends, separating smoothly into its constituent spectrum of colors through the steady, predictable mechanics of refraction and internal reflection. The light does not hurry as it bends through the subtle curvature of water, but travels with an unhurried rhythm that transforms passing rainfall into a quiet band of beauty painted against the backdrop of gray clouds. In this soft optical theater, the atmosphere demonstrates how deep order and serenity naturally emerge from simple physical laws, inviting the observer to rest under a sky governed by calm, enduring geometry. Sometimes, when atmospheric conditions are exceptionally tranquil and sunlight strikes the falling moisture at just the right angle, a second, fainter rainbow forms above the primary arc. Between these two shimmering pathways of colored light, a subtle and serene phenomenon presents itself to those who quietly look upward at the evening sky. Around 200 AD, Greek philosopher Alexander of Aphrodisias described the dark ribbon of sky resting between double rainbows, revealing how light refraction leaves an unlit angular gap of roughly 8 degrees between the primary and secondary rain arcs. Within this calm expanse, known today as Alexander's Band, light reflected inside the raindrops is directed away from the eye of the observer, leaving a soft band of sky that appears noticeably darker than the surrounding atmosphere. There is a peaceful elegance in this quiet shadow, offering a soothing reminder that light and darkness work together to define the graceful shapes we observe against the cloudscape. Primary rainbow directs scattered light downward, while while the inverted reflections of the secondary arc direct light upward, preserving this central sanctuary of muted shadow between them, as if the sky itself had paused to create a space of deep rest. As the sun dips lower toward the horizon, the precise angular relationship between the sunlight, the raindrops, and the observer slowly shifts, allowing the colorful arcs and their dark intervening band to softly dissolve into the gathering dusk. The water droplets continue their quiet, gentle descent toward the moist earth, carrying with them the soft humidity that nourishes slumbering fields and quiet forests below. Above, the cloud ceiling softens, its crisp edges smoothing into ambient gray, gentle slate, and deep violet hues as the last rays of daylight fade away. The atmosphere settles completely into its nocturnal rhythm, exchanging the brilliant optics of daytime refraction for the cool, still air of nighttime condensation. In this quiet transition, the sky loses none of its gentle wonder, holding the quiet memory of light within its humid folds, while inviting the world below to rest deeply in its peaceful stillness. High above the quiet valleys, where the earth reaches upward into the cooler strata of the atmosphere, moisture gathers not in heavy storm clouds, but in a delicate, shifting veil of mountain mist. Here, the air moves with a slow and rhythmic grace, carrying invisible water vapor up along the gentle contours of green slopes, until the ambient temperature falls just enough for condensation to begin. In these serene upper reaches, the moisture remains light and almost weightless, floating upon quiet thermal currents like a soft breath exhaled by the land. The world at these high altitudes is hushed, wrapped in a cool stillness where the boundaries between earth and sky dissolve into soft shades of gray and muted white. As the damp air drifts across the high ridges, the sun does not encounter the heavy, rounded drops of rain that sculpt the bright, dramatic arcs of a rainbow, but rather millions of microscopic spheres suspended in absolute tranquility. It was amidst such silent altitude, while observing mist atop Mount Pambamarca in Ecuador in 1735, that Spanish astronomer Antonio de Ulloa documented the fog bow, showing how sunlight softly diffracts through microdroplets under 0.05 millimeters to weave a serene, colorless halo across the quiet sky. Unlike the bold primary colors born of refraction in larger falling raindrops, these tiny suspended droplets of fog are so small that the wave nature of light comes gently to the fore. Instead of separating cleanly into distinct bands of red, yellow, and blue, the rays of sunlight bend and overlap around the fine edges of each microscopic sphere. This subtle process of diffraction diffuses the spectral hues back together, smoothing the vibrant colors into a quiet, luminous arc of pale ivory and soft, pearlescent white. To stand before such a display is to witness a subtle miracle of atmospheric physics, a bow of pure light resting gently upon the mist, glowing without clamor or intensity. This soft optical harmony reflects the quiet order inherent in the upper air, where small scales of moisture create profound visual peace. When cloud droplets are exceptionally minute, their physical behavior changes, allowing light to wander through the vapor in a way that feels cushioned, soft, and endlessly calm. As the sun moves lower on the horizon, the pale ring of the fog bow gradually fades into the surrounding haze, leaving behind only the steady, rhythmic breathing of the mountain atmosphere. The tiny droplets continue their silent drift, gradually cooling in the dimming light, cradled by the calm pressure of the surrounding air. In this peaceful balance between liquid moisture, ambient light, and elevated terrain, the atmosphere offers a comforting rhythm of renewal and rest. As twilight deepens across the high mountain peaks, the mist settles into an even quieter stillness, cradling the landscape in cool embrace. The light that once wove bright arcs across the sky now softens into a gentle, uniform glow, merging seamlessly with the quiet arrival of evening. Each microdroplet continues its weightless dance, suspended in the vast and silent air, holding the calm memory of sunlight within its tiny form. In this slow, atmospheric movement, the world invites a deep and resting breath, wrapped in the quiet science of mist, light, and sky. As the late afternoon sun hangs lower over quiet mountain ridges, the atmosphere engages in a subtle, reassuring play of light and moisture. The air, cooled by rising altitudes and softened by the approach of evening, holds countless suspended water droplets in delicate equilibrium. These microscopic spheres, drifting through the high elevation mist, act not merely as passive vapor, but as gentle prisms and diffusers of ambient light. When wind gently nudges a layer of fog across a high peak, it carries with it a stillness that seems to slow time itself. Up here, where the earth meets the lower boundary of the cloud realm, light does not simply pass through the air. It weaves through liquid microstructures, bending, spreading, and revealing the unseen geometry of atmospheric optics. The surrounding world grows muted, wrapped in a blanket of cool gray and pale silver, while soft thermals carry the moist air upward into the darkening sky. In these high places, the boundary between cloud and mountain vanishes into a peaceful, luminous breath of moisture and shadow. This serene interplay between light and mist has long captivated those who wandered into the high solitudes of the earth. In September 1780, German pastor Johann Essius Silberschlag recorded the mountain glory on the peak of the Brocken, describing how low afternoon sunlight diffracts through uniform mist droplets to wrap an observer's shadow in a quiet, multicolored halo. Standing atop the foggy summit with the sun declining behind him, he observed his own cast shadow projected outward onto the sea of cloud below, encircled by delicate rings of radiant indigo, rose, and amber. Unlike the familiar arc of a distant rainbow, which relies on larger falling raindrops reflecting light from behind, this glory stems from light waves diffracting around minuscule droplets of remarkably uniform size. As each beam of sunlight grazes the curved surfaces of these microscopic water spheres, the light waves interfere with one another, fanning out into concentric bands of soft, spectral color. It is a spectacle born from pure harmony in nature, a moment where microphysics and sweeping landscape meet to transform a simple shadow into an ethereal portrait framed by light. As afternoon turns inevitably toward dusk, the intensity of the light softens even further, blurring the vivid edges of the glory, until only a faint silver glow remains around the summit contours. The air begins to settle into its soothing nocturnal rhythm, cooling as the sun sinks below the horizon, and reducing the gentle thermal currents that lifted the valley moisture upward earlier in the day. Within the mountain clouds, millions of tiny water droplets collide and coalesce gently, or float suspended in the quiet air, waiting for the night sky to clear into darkness. The mountain itself seems to sink into deep repose, swallowed by the expanding darkness and the cool, humid air that wraps around every peak and pass. Watching the last spectral colors dissolve into the twilight reminds us of the delicate balance governing our atmosphere, where subtle physics creates moments of quiet beauty before giving way to the stillness of night. With each passing minute, the high winds calm, the fog rests softly against the granite slopes, and the atmosphere settles into a peaceful, unbroken sleep. High in the quiet expanses of the upper atmosphere, where the air grows cold and steady, delicate veils of cirrus clouds slowly unfurl across the sky like soft ribbons of silver thread. These distant, feather-light clouds reside in a realm of calm, composed not of liquid water droplets, but of tiny suspended ice crystals formed directly from atmospheric vapor in sub-zero stillness. Each microscopic crystal is crafted into geometric perfection by the quiet laws of ice growth, forming tiny six-sided columns and flat hexagonal plates as the warm afternoon light begins its gradual descent toward the horizon. Its rays pass gently through this vast canvas of ice, turning the sky into a luminous sanctuary of light. For centuries, observers looking up at these quiet afternoon skies were captivated by the pale circular arcs and glowing spots of light appearing alongside the sun, wondering what gentle atmospheric rhythms transformed ordinary sunbeams into such tranquil optical wonders. The scientific inquiry into these luminous sky phenomena deepened during the early 17th century, when natural philosophers sought to explain the geometry behind the upper atmosphere's quiet displays. In 1629, after astronomer Christoph Scheiner observed a serene, multi-ringed solar halo over Rome, French philosopher René Descartes showed how afternoon sunlight refracts through millions of microscopic, floating hexagonal ice prisms in high cirrus clouds to form the glowing sky rings Descartes realized that as sunlight enters one face of these six-sided column-like prisms and exits through another, the light bends in a precise, predictable path governed by the refractive properties of ice. The cumulative effect of countless microscopic refractions occurring across millions of ice crystals drifting high above the Earth creates a soft halo around the sun. This ethereal ring, shimmering with faint pastel shades, encircles the afternoon sun with effortless geometric symmetry, lulling the mind into peaceful contemplation. Beyond the complete circular halo, another serene optical spectacle sometimes graces the high cirrus clouds, appearing as luminous patches of light flanking the sun near the horizon. In 1681, French physicist Edmé Marriott showed that sundogs form when flat, hexagonal ice crystals in high cirrus clouds drift slowly downward like falling leaves, refracting afternoon sunlight at an exact 22-degree angle. Unlike randomly oriented ice columns, these thin plate crystals align horizontally as they sink through calm air layers, floating gently on subtle atmospheric currents like golden leaves settling toward a quiet forest floor. When the afternoon sun shines through these horizontally aligned plates, light enters one vertical side face and exits through another, bending light outward at that specific, constant angle. This gentle interplay of geometry and gravity produces two soft, glowing mock suns shimmering on either side of the solar disk. As twilight advances and the sun drops lower toward the resting Earth, these high ice crystals continue their silent, weightless journey through the cold upper atmosphere. The brilliant mock suns and pale halos slowly soften, melting into the quiet purple and amber hues of dusk. In this tranquil twilight, the atmosphere rests in effortless harmony, governed by the delicate physical laws that shape our sky. Every floating crystal and bending ray of light contributes to a continuous, calming rhythm that cradles the world in soft, peaceful quietude. Across the vast expanse of our planet, the atmosphere moves in a continuous, graceful breath, driven by the quiet geometry of light and warmth. High above the tropical oceans, where the sun sits nearly overhead, the surface of the waters receives a rich abundance of radiant energy, absorbing the golden light throughout the long, peaceful hours of the day. As this gentle warmth accumulates, the air resting directly above the sea expands, growing lighter and softer than the cooler layers lingering in the upper reaches of the sky. This invisible transformation gives rise to a slow, majestic movement, where moist air begins its steady, unhurried ascent into the atmosphere. As these gentle currents rise, they cool gradually in the thin altitude, releasing their moisture into shimmering fields of shallow cumulus clouds that float like pale feathers across the soft blue horizon. There is a deep, quiet harmony to this global circulation, a ceaseless exchange of heat and air that balances the temperatures of our world with patient, enduring persistence. The understanding of this grand atmospheric rhythm has long inspired those who study the subtle patterns of the sky. In May 1735, English scientist George Hadley submitted a paper to the Royal Society explaining how equatorial sunshine gently warms tropical surface air, causing soft updrafts that quietly drift toward 30 degrees latitude before settling into the calm trade winds. This elegant circulation model, which would eventually bear his name as the Hadley cell, revealed that the air does not simply rise and vanish into space, but instead forms an endless loop of soothing movement across vast geographic distances. Upon reaching the upper boundary of the troposphere, the cooled tropical air turns outward, gliding peacefully toward the north and south. As it travels high above the weather systems below, far from the intense heat of the equator, it gradually sheds its warmth into the cool expanse of space, becoming denser and heavier with every passing mile. This high-altitude journey is quiet and undisturbed, carrying thermal energy across thousands of leagues, while the ocean beneath sleeps soundly under the twilight sky. Eventually, as these high-altitude currents arrive near 30 degrees latitude, their gentle northward and southward momentum slows, and the heavy air begins its tranquil descent back toward the surface of the earth. As the descending air compresses under its own weight, it warms naturally, melting away any remaining wisps of cloud and leaving behind vast belts of clear, serene skies. Here, in these subtropical latitudes, the air rests upon the ocean waters with a soothing stillness, creating calm seas and steady pressure systems that have guided sailors across the globe for centuries. Once near the surface, this refreshed, cool air turns gracefully back toward the equator, drawn naturally to complete its timeless loop. These returning currents form the steady, dependable trade winds, winds that flow with a soft, unwavering rhythm, whispering gently across the ocean surface. In this perpetual cycle of rising, drifting, descending, and returning, the Earth maintains a delicate atmospheric balance, reminding us of the steady, comforting rhythms that continuously cradle our world in quiet equilibrium. High above the sleeping world, far beyond the soft whisper of evening surface breezes, great rivers of air move in continuous, stately motion through the upper atmosphere. In these high, quiet altitudes, where the air grows thin and cold, the planet's vast breath is shaped by deep celestial mechanics. The atmosphere does not rush in random paths. Instead, it glides across the globe in majestic, wide curves, drawn forward by the gentle physics of fluid motion on a spinning globe. As twilight fades into night, these high-altitude winds carry thermal energy from warm tropical expanses toward the silent frost of the poles, maintaining a soft, equilibrium-seeking harmony across the continents. The quiet rotation of the planet below exerts a subtle, constant nudge upon these moving masses of air, imparting a rhythmic sway that guides clouds and weather across thousands of miles of midnight sky, allowing the night below to remain soft, calm, balanced, and profoundly serene. It was through careful observation of these high-altitude currents that atmospheric science uncovered the subtle mathematics guiding global wind patterns. In the quiet year of 1939, Swedish meteorologist Carl Gustav Rossby published the elegant mathematics of planetary atmospheric waves, showing how Earth's quiet rotation sways upper jet streams into long, undulating meanders that rhythmically balance planetary warmth. These colossal atmospheric waves, sweeping smoothly around the northern and southern hemispheres, function as planetary heat exchangers. Their wide, curving loops carry equatorial warmth toward colder latitudes, while inviting cool air to drift southward, preventing extreme thermal contrasts and keeping the global climate gently tempered. As humanity slumbers below, these giant waves move with glacial grace, drifting slowly eastward and cradling subtle pressure variations that bring soft rain, drifting cloud decks, and clear starry skies to different regions of the world, maintaining the Earth's gentle temperature balance through every season. To visualize these planetary waves is to imagine the atmosphere as a quiet, translucent ocean whose giant currents ripple in slow, majestic harmony across thousands of leagues. Within the upward curve of a wave's trough, air ascends gently, cooling as it slowly rises to form delicate, feather-like cirrus clouds that catch the fading starlight. Within the descending ridge, air settles down smoothly, clearing the sky into vast, quiet expanses of peaceful dark and still quietude. This continuous rise and fall of atmosphere occurs over vast geographical spans, bridging oceans and continents in a single fluid gesture. There is a deep comfort in knowing that the sky above is never chaotic or unpredictable, but governed by timeless mathematical laws that continuously maintain balance, warmth, and order across the globe. As the night deepens and deep silence settles over the Earth, the planetary waves continue their tranquil, low-frequency voyage around the dark side of the world. The upper jet streams flow like silver ribbons in the high atmosphere, carrying high-altitude moisture in long, serene arcs across quiet mountain ranges, sleeping valleys, and darkened plains. Every bend in the wind and every shifting cloud bank is part of this grand atmospheric symphony, responding faithfully to the steady, silent turn of the Earth. Wrapped in this vast, protective cushion of moving air, the land rests peacefully under the quiet stars, cradled by the perpetual, soothing rhythms of the sky as sleep gently takes hold. As the planet turns beneath the quiet gaze of the stars and the soft, shifting light of day, the vast envelope of air surrounding us executes an imperceptible, rhythmic breathing. High above the soaring clouds, where sunlight gently brushes the thinnest upper reaches of the sky, a quiet thermal swell takes shape without sound or struggle, driven by the sun quietly warming the upper ozone layer global atmospheric thermal tides cause the air pressure across Earth to rhythmically rise and fall twice each day by roughly 2 millibars. This subtle barometric pulse moves continuously around the globe like a slow, invisible wave sweeping across a calm ocean, balancing temperature and density in an eternal, restorative movement. Far down on the Earth's surface, as evening deepens and night settles over peaceful hills, this tender atmospheric rhythm cradles the world in a steady, reassuring ebb and flow. The subtle rise and fall of the barometric tide mirrors the slow, natural rhythm of sleep itself, soothing the terrestrial world with its soft, predictable cadence. In the high pastures of the Swiss Alps, where mountain slopes rest beneath gentle sheets of evening mist, naturalists long ago sought delicate ways to listen to these subtle atmospheric shifts. In 1783, Swiss naturalist Horace Benedict de Saussure constructed the first hair hygrometer in Geneva, discovering that a single strand of human hair softly expands in damp evening air to measure the quiet accumulation of moisture-forming high mountain fog. With exquisite simplicity, this fine strand would react to the unseen water vapor drifting through the alpine air, lengthening softly as ambient moisture wrapped around its delicate organic fibers, and relaxing gently whenever the surrounding atmosphere grew clear. It offered an extraordinary window into the quiet mechanics of weather, illustrating how even the smallest elements of life respond to the overarching breath of the sky, mirroring the very process that turns invisible vapor into soft clouds along mountain ridges. This elegant relationship between microscopic organic strands and vast atmospheric currents reminds us of the delicate balance sustaining the living world. As evening deepens, moisture gathers silently in the cool air, adhering to leaves, grass, and tiny strands, while the overarching sky maintains its quiet, ancient rhythms. The atmosphere acts as a gentle, breathing vessel, holding warmth and moisture in perfect proportion as day slowly softens into night. The quiet condensation forming on mountain slopes is not an isolated event, but a single movement within a grand, harmonious symphony of atmospheric physics. Every droplet of mist moves in gentle accord with the planet's continuous thermal pulse, wrapping the valleys in absolute tranquility. As we look out across the quiet expanse of the night, or watch the fog settle effortlessly over silent meadows, there is a profound stillness in knowing that the atmosphere around us is governed by such graceful harmony. From the vast planetary scale of global thermal tides pulsing twice daily through the stratosphere to the tiny, tender elongation of a hair strand measuring dew in a quiet valley, the air remains in continuous, serene equilibrium. The air pressure gently eases like a warm blanket resting over the sleeping earth, while cool night air holds the gathering humidity with absolute calm. As the hours drift on, these peaceful atmospheric rhythms continue their unhurried work, guiding the world into a deep, restful slumber beneath the quiet, watchful skies. As twilight gradually gathers along the quiet edges of the evening sky, the atmosphere settles into a peaceful, cooling rhythm. The bright daylight that once warmed the air softens into a tapestry of deep indigo and velvet blue, while the lowest layers of the sky retain a warm, ember-like glow. High above the darkening earth, slender cirrus clouds and distant cloud banks float as gentle, motionless silhouettes, capturing the final remnants of the sun's journey below the horizon. As the sun dips lower, its rays travel through an increasingly long path of dense, layered air near the surface. This vast blanket of atmosphere acts as a quiet lens, bending and softening the incoming light in a slow, tranquil progression. The air grows still during this hour as the thermal currents of the day gently subside, allowing the moisture in the sky to rest in smooth, unbroken strata. The evening transition is a subtle dance of thermodynamics and light, where temperature gradients in the air shape the path of every beam, creating long, serene shadows that stretch across the land and merge into the restful quietude of nightfall. Within this peaceful evening display lies a delicate optical harmony governed by the physics of atmospheric density. As sunlight passes through the curving layers of air, the different colors of the light spectrum bend at slightly different angles, behaving much like light passing through a massive, tranquil crystal. In 1881, English physicist Lord Rayleigh mathematically explained how Earth's atmosphere acts like a gentle curved prism at dusk, refracting sunlight so that the last lingering ray above a distant cloud beam glimmers in a soft, calm emerald flash. Because red and orange light are refracted less and sink below the horizon first, while blue light is scattered away by the air molecules themselves. The clear, middle wavelength of green light is briefly separated and lifted into view for a fleeting, quiet moment. This emerald glimmer, hovering just above the upper boundary of a cloud or the oceanic rim, is a testament to the elegant precision with which the atmosphere scatters and refracts light. It occurs without fanfare, a subtle whisper of optical geometry that rewards only the calmest and most patient observer watching the horizon as the final colors of dusk gracefully dissolve. With the passing of that quiet green beam, the sky shifts gently into the profound calm of true evening. The high clouds, having lost their final golden highlights, fade into soft gray veils that slowly merge with the darkening vault above. As the ground cools under the open sky, a shallow boundary layer of cool, dense air forms near the earth, insulating the surface and preserving the tranquil stillness of the night. The water vapor within the cooling air continues its timeless, quiet rhythm, occasionally condensing into fine, microscopic dewdrops on resting leaves, or remaining suspended as delicate, nocturnal mist. Everything in the atmosphere moves toward balance and rest, as the energetic motion of daytime heating gives way to the serene equilibrium of darkness. The winds drift into soft, whispering breezes that gradually fade into complete stillness, leaving only the steady, quiet presence of the star-filled sky. Underneath this vast canopy of atmospheric grace, the world pauses, wrapped in the cool, restorative peace of another completed day. As the sun slowly descends toward the quiet rim of the evening sky, the broad landscape of the atmosphere begins its shift into a calmer, softer mode of light. Lower clouds that once glowed with the warm amber of fading day gradually yield their brilliance, settling into gentle shades of lavender and dusky gray. Up above, high in the tranquil reaches of the upper troposphere and lower stratosphere, thin veils of cirrus and high-altitude ice crystals hold onto the last remnants of daylight. The light filtering through this vast expanse of upper air undergoes a subtle, delicate transformation as the angle of the sun grows low along the horizon. Sunlight must now travel through an immense thickness of air, where standard molecular scattering shifts the balance of spectral hues in a soothing, predictable rhythm. The atmosphere acts as a vast, quiet filter, sifting through the spectrum to bathe the evening sky in a profound, lingering calm. Air currents that were lively during the sunlit hours begin to ease into gentle whispers, smoothing out the thermal contours of the lower sky and allowing the clouds to rest like soft, brushed ribbons against the darkening canvas. It was during the quiet laboratory study of atmospheric gases in 1880 that French chemist James Chapuis discovered that molecules in the upper ozone layer absorb orange sunlight at dusk, casting a tranquil, deep cobalt blue light onto high twilight cloud layers in a phenomenon known as Chapuis absorption. This gentle filtering of light creates the ethereal blue hour that skywatchers have cherished across generations. As the warm orange and yellow wavelengths of the low-angled sun are quietly absorbed by ozone high in the stratosphere, leaving behind only the rich, restful indigo and cobalt tones to illuminate the evening air. High atmospheric cloud structures, resting far above the darkening surface of the earth, catch and reflect this filtered cobalt glow, standing as soft, luminous silhouettes against the deepening dome of twilight. The subtle science behind this evening transition reminds us of the delicate, invisible balance within the upper air, where simple molecular interactions shape the very colors that invite the world below to pause, breathe, and rest. With each passing moment, the cool cobalt light deepens across the highest cloud decks, signaling to the world below that the daylight hours have softly drawn to a close. Atmospheric rhythms slow into steady evening drifts, carrying gentle moisture across cooling lands, while thermal columns sink back into quiet stability. The subtle shift from the bright energy of afternoon to the deep, blue-hued stillness of dusk reflects the continuous, restful breathing of our planet's atmosphere. Underneath this indigo blanket, clouds lose their sharp edges smoothing into soft, floating veils that cushion the transition into twilight. As the first evening stars slowly prepare to reveal themselves, the sky rests in the calm embrace of filtered sunlight, allowing the night to unfold with effortless grace, steady balance, and timeless, peaceful tranquility. Across the wide expanses of land and ocean, the air grows quiet and still, wrapped in the protective, cooling embrace of the evening twilight, as sleep falls gently over the land. As twilight recedes into the quiet stillness of night, Earth embarks on one of its most delicate atmospheric rituals. Throughout the long daylight hours, the soil, stones, and leaves absorb the sun's gentle warmth, storing thermal energy beneath the open expanse of the daytime sky. But when night arrives and the air turns clear and calm, this stored warmth begins a slow, invisible journey upward. Without the shielding presence of cloud cover, the terrestrial landscape silently radiates its heat energy out into the cold expanse of space, allowing the ground temperature to drop continuously through the tranquil nighttime hours. This process of radiative cooling creates a subtle boundary layer where air touching the soil becomes significantly cooler than the air floating just a few meters above. As the ground chills, it gently pulls heat away from this adjacent air, slowing the movement of water vapor suspended within it. This quiet mechanism of ground cooling remained largely a mystery until a patient observer sought to understand how the earth gathers its evening moisture. In 1814, Scottish physician Charles Wells conducted nightly garden experiments in Surrey, using delicate tufts of wool to demonstrate how ground mist forms when Earth silently radiates its heat into space, cooling the surface air down to its dew point. By placing light bundles of wool upon the grass and suspending others above the soil, Wells carefully measured the small differences in temperature and accumulated moisture. He observed that surfaces with a clear view of the open sky lost their heat rapidly, chilling the air until it could no longer hold its vapor in a gaseous state. His work proved that mist and dew are not light rains falling from distant clouds, but intimate local phenomena born from the Earth's direct exchange with space. When surface air reaches its dew point, relative humidity near the ground achieves total saturation, prompting water molecules to condense onto any resting surface. Microscopic droplets gather along the delicate tips of meadow grass, fine spider threads, and tiny soil particles, weaving a luminous veil across low pastures and quiet fields. This ground mist is effectively a cloud in its most humble form, resting comfortably against the landscape rather than soaring high in the sky. The windless calm of night preserves these fragile suspensions of moisture, allowing fog to linger softly in shallow hollows. The slow formation of these low-lying clouds follows a comforting rhythm, matching the gradual cooling of the sleeping earth beneath a dark canopy of stars. As night deepens, this soft shroud of mist acts as a gentle buffer, slowing the further loss of heat and stabilizing the nocturnal environment. The air remains motionless, held in a serene thermal equilibrium where condensation and evaporation reach a quiet, effortless harmony. Moving through such a landscape, one feels the profound peace of an atmosphere at rest, where physical laws manifest not as sudden storms, but as the quiet emergence of silver dew and drifting fog. In this slow nocturnal cadence, the atmosphere gently prepares the terrestrial world for the coming dawn, wrapping the quiet earth in a soft blanket of moisture, until morning light warms the distant horizon once more. As twilight yields to the soft quiet of night, the ground begins to shed the heat accumulated during the sunlit hours. This gradual cooling brings about a peaceful restructuring of the atmosphere near the Earth's surface, where the friction of daytime turbulence yields to a steady, frictionless calm. As the lower air settles into rest, the upper layers of the boundary atmosphere are released from the drag of the terrain below. In 1957, American meteorologist Alfred Blackadar demonstrated how evening surface cooling decouples air layers, allowing a silent nocturnal low-level jet stream to glide smoothly over the Great Plains and transport gentle streams of moisture across the night sky. This dark, invisible river of air flows uninterrupted through the quiet night hours, nourishing the atmosphere far from its origin with an unseen, humid breath. Long after the land below has surrendered to sleep, this high-altitude current continues its tranquil journey, carrying the essential ingredients for future clouds across hundreds of miles. The movement is so smooth and unhurried that one standing beneath the starry vault would feel only the gentlest breeze, unaware of the vast, moisture-laden current passing silently overhead, rising far above this nocturnal stream of air, high above the highest wisps of tropospheric clouds, lies a realm of perpetual equilibrium and silence. For many years, scientists assumed that the air grew colder and colder. Without limit, the higher one ascended into the heavens. Yet, the true nature of the upper air was revealed through patient nocturnal observation beneath quiet French skies. In April 1899, French meteorologist Léon Tesserenc de Bort launched over 200 instrumented paper balloons at night from his observatory in Trappes, discovering the tranquil stratosphere where air temperature remains at a gentle, constant -55 degrees Celsius above the clouds. These delicate paper sentinels drifted upward through the shadowy atmosphere, carrying self-registering thermographs into an unsuspected region of constant temperature, where convection ceases and the air settles into harmonious, horizontal layers. Here, above the turbulent weather of our lower world, the atmosphere rests in undisturbed serenity, shielded from the churning storms below. The discovery of this calm stratospheric sanctuary changed our understanding of the atmosphere forever, proving that even in the vast heights above our world, nature finds a place of enduring peace and stability. together. These nocturnal rhythms reveal how the sky maintains its delicate harmony while the world rests in darkness. From the silent low-level jet stream gliding over mid-continental plains to the vast, unchanging stratosphere soaring high overhead, the atmosphere operates like a grand, quiet timepiece. The cooling of the earth acts as an invitation for these invisible currents to shift, bringing moist air to places that will awaken under soft morning mists, while the distant stratosphere holds its steady, frozen calm above it all. There is a deep comfort in knowing that even when human activity pauses and the landscape grows still, the atmosphere continues its gentle work of circulation and renewal. The air moves without friction. The temperature stabilizes into enduring balance, and the night sky breathes with a slow, reassuring cadence. As you rest beneath this immense canopy, you can imagine these peaceful currents floating across the globe, carrying water vapor, cradling silent cloud layers, and maintaining the tranquil equilibrium that sustains our living world through every passing hour. As twilight deepens across the lower reaches of the atmosphere, the earth below settles into quiet repose. The broad cumulonimbus towers that painted the afternoon sky with dynamic convective currents gradually lose their energetic thermal engines, flattening into soft, horizontal sheets of evening stratus. Down here, near the surface, the air grows still and cool, resting upon the darkening ground like a heavy, protective mantle, yet high above the everyday, whether we experience in our daily lives. Far beyond the serene altitudes, where cirrus wisps drift in sub-zero currents, lies the mesosphere, a place of extreme cold and ultimate stillness. At the absolute edge of space, where the atmosphere thinks in vast, multi-day planetary waves, the quiet rhythms of night begin to reveal their most delicate secrets. The sun may have dropped well below our local horizon, leaving the landscape beneath us bathed in indigo shadow, but its low, golden rays continue to angle upward through the vast vacuum of space, illuminating the highest and most distant boundaries of our world. In this remote, frigid realm 80 kilometers above the resting Earth, the atmosphere transforms into a canvas of serene, otherworldly wonder. Here, faint and ethereal tendrils of silver light assemble in the high summer night, glowing with a soft, electric blue radiance that seems to float entirely independent of the terrestrial dark. First documented by Robert Leslie in June 1885, silvery noctilucent clouds form 80 kilometers high in the frozen mesosphere, clinging to microscopic dust left behind by fallen shooting stars. These night-shining ice sheets represent the highest cloud structures on Earth, existing in a realm so sparse and dry that water vapor must seize upon the lingering cosmic debris of meteors just to crystallize into form. They float as delicate gossamer veils, softly rippling under the gentle influence of atmospheric gravity waves that pass through the mesopause like silent ocean swells across a cosmic shore. To watch them from below is to witness a quiet conversation between the planet and the cosmos, where the dust of ancient cosmic wanderers becomes a graceful vessel for frozen moisture, illuminated by sunlight that has traveled across thousands of miles of space. As the hours drift slowly toward midnight, even these luminous high-altitude veil clouds seem to soften and fade gently into the quiet background of the starlit sky. The global atmospheric engine, which works untiringly by day to redistribute the heat of the sun, slows its pace in the shadow of night. Air molecules, settled in their subtle thermal strata, pulse with the slow, rhythmic breathing of global tides. From the warm moisture evaporating off tropical seas to the icy crystals hovering at the threshold of space, the air has accomplished its daily harmony. Everything is held in a vast, balanced embrace, suspended between gravity and thermal warmth. As you listen to the subtle shifts of the night air outside your window, feel the quiet stability of this atmospheric canopy surrounding the globe. It protects, it breathes, and it slumbers alongside the sleeping world below. Rest now in this tranquil rhythm as the sky continues its peaceful, timeless watch overhead, letting the cool stillness of the night carry you effortlessly into deep, restful, and unbroken sleep.